Hello, and welcome to our video on the law of conservation of energy. This fundamental law states that energy cannot be created or destroyed, only transformed from one form to another form. In this video, we'll explore two key forms of energy, potential energy and kinetic energy, and we'll also see how they are interconnected. Potential energy is stored energy. It's the energy an object possesses due to its position or state. For example, a ball at the top of a hill has gravitational potential energy because of its height. The higher the ball, the more potential energy it has. Kinetic energy is the energy due to motion. Any object that is moving has kinetic energy. The faster an object moves, the more kinetic energy it has. For example, a rolling ball has kinetic energy because it's moving. Now, let's see how potential and kinetic energy can transform from one to another. Imagine a roller coaster car at the top of a hill. At this point, the car has a lot of potential energy due to its height. As the car starts to descend, its potential energy is converted into kinetic energy. The faster the car goes, the more kinetic energy the car gains. Conversely, when the roller coaster car ascends another hill, its kinetic energy is converted back into potential energy. The higher the car climbs, the more potential energy it gains. This continuous transformation between potential and kinetic energy is a key concept in the law of conservation of energy. Let's look at some real-world examples of potential and kinetic energy transformations. A swinging pendulum demonstrates this beautifully. At its highest point, the pendulum has maximum potential energy. Observe how the pendulum bob is not moving, which means the bob has a speed of 0 and 0 kinetic energy. As the pendulum swings downward, this potential energy is converted into kinetic energy. At the bottom of its swing, the pendulum has maximum kinetic energy and minimum potential energy. As the pendulum swings back up, the process reverses. The bob slows down with kinetic energy being converted back into potential energy. Note how the bob reaches its fastest speed at the bottom of the swing when its kinetic energy is the greatest. A stretched spring stores potential energy. When released, this potential energy is transformed into kinetic energy, causing the spring to expand and contract. As the spring begins to compress, the kinetic energy is changed into potential until the spring compresses and the stretch-compress cycle is repeated. When you draw back a bowstring, you're storing potential energy in the bent bow. When you release the arrow, this potential energy is converted into kinetic energy, propelling the arrow forward. The law of conservation of energy is a fundamental principle in physics and has far-reaching implications in various fields, from engineering to environmental science. Understanding this law helps us analyze and predict the behavior of systems in a wide range of contexts. I hope you enjoyed this video on the law of conservation of energy. Thank you for watching.